All right, welcome, future teachers. We're going to go ahead and get started into 10.4, which will be the last section of this unit. You should be able to finish um, dealing with this chapter. So just be aware of you should be getting a message. There is tutorials on Wednesday, so hopefully you should be able to use that. Okay. So let's go ahead and get into this because this is a very um, long section. Okay, this may take a little bit of time. Let me go ahead and get back to the beginning of this. All right, so we are going to go ahead and get into this chapter, last section of this chapter. This one is on data and statistics analysis. So there's some technical stuff in here, some formula stuff in here that I'm going to have to figure out how to deal with on tests, especially everything online. But I'll have that figured out before and send you an email on how that's going to work. So, because then look at all the stuff we got to go through. All right, so central tendencies, these are things you've done before: mean, median, mode, when to use those type of central tendencies, measures of spread. We'll use a little bit of that. We'll talk about what that means because it is built into the box plots. Comparing some of that variance and standard deviation. Here's where the formulas are going to come in. Normal distribution, your old bell curve, and percentiles and quartiles and deciles, deciles. I can never say that word. All right, so it says measures tendency. Two important aspects of data are its center and its spread. Okay, center knowing as the middle, right? So some essential tendency, when we talk about central tendency, this is when we are dealing with the mean and median. Okay, and you'll remember the other ones too. These describe where the center is. Okay, the mean is your average, right? The median is the middle. Okay, so we are talking about where it is in the center. Then you have what's your range, your interquartile range, variance, mean, absolute deviation, and standard deviation are on how far apart your numbers are spread and spread equally and that kind of thing. Okay, so that's what when they talk about center and spread. Now we'll go through a few of these pretty quick. So computing means is your average. Okay, you guys know how to average. Add up all of them, divide by the number of things you added, and that is your average. Okay, the part you need to understand is because in formulas you're going to need to know this is this always the symbol always means average. Okay, the average of those numbers. So when you see that symbol, the X with the line over it, you need to understand that means average. Okay, that's going to be very important in a lot of things we talk about. Okay, that's the arithmetic mean. Okay, that's the bar that we're talking about. All right, so when we find the mean, it says the mean of 5 is the balance point, where the sum of the distances from the mean to the data points above the mean equals the sum of the distances from the mean of the data points below the mean. Okay, so it's kind of how, because these are farther apart, but if you think of it as a balance, these would weigh 18 over here, these would weigh, let's see, the 6, 12 and that your average here is going to be your 5. Okay, it kind of keeps it balanced. Okay, the sum of the distance between the mean is 8. The sum of the distance between them below the mean is also 8. Okay, so we look at those. So data are centered about the mean, but the mean does not belong to the set of data sometimes. Now that's sometimes it can be part of your data, but a lot of times the average is not part of your data. Okay, so it is possible to rearrange the data to have the same mean, but be spread very differently. Okay, so notice here you have these numbers are all in positive realm. Okay, when you add them up, you find the average is 5. Here you have some negative numbers and then way much bigger positive numbers, but their average is still 5. Okay, so that balance point can kind of be be a little bit different than what you would normally see. Okay. The value exactly in the middle. So we know we're talking about the middle, which you know is the median. Okay. One of the things you have to do first is you have to have the numbers in order from least to greatest. Now there is a technical thing that you could do it greatest to least and still find your median because it still be in the middle. But usually we want to make sure the kids get kind of in a habit of putting things smallest to biggest. Okay. Now we know that there's two different ways you can have a median. One is if there are an odd number of numbers, the median is going to be smack dab in the middle. Okay. If there's an even number, the median has to be the two in the middle. Then are added up and divided by 2. Okay. It says the median is often reported as the interquartile range, a measure that spreads that shows where the middle 50% of the scores lie with the median in that range. The two together form a much better pair to describe the data than the median alone. Okay, and that's just talking about making sure when you do have an even number of numbers that you're dealing with, you take the 2 and you add them up, divide by 2. Okay, the mode is the one that happens the most. Okay, so you have median. Median has a D in it, so does middle, but so does mode. But people kind of relay those together, mode and most. Okay, the one that happens is frequently being says sometimes reported as the measure of central tendency, but when it is reported in that form, it is frequently being misused. The mode is a set of data. The set of data is the number that appears most frequently. If there is one, but the mode does not have to be in any way a measure of central tendency. And the mode is frequently reported with categorical data. All right, so real quick, you can go through these, find the mean, median, mode. Okay, I would always teach my kids, put them in order first. Okay, even if you don't need to have them in order, just go ahead and put them in order. Get in that habit. Okay, notice there are 6 numbers here. Finding the median, or the mean, excuse me, add them up, divide by 6. The average is, or the mean is 80. Okay, says the data is arranged from least to greatest, and there is an even number of data. So the median is the middle. Remember what we do is we're going to take the 2 in the middle, add them up, divide by 2, and you're going to have a median at 82 and a half. Obviously not a number that's in there, but that is smack dab in the middle. All right, and then the mode, which one happens the most? Okay, notice you have 60 happens twice, 95 happens twice. So this data is actually bimodal because you have 60 and 95 happen the most times. Okay, if you only have one number that keeps repeating, it really doesn't have a mode. Okay, you could have just 2 numbers that 3 of one and 3 of the other. That's fine too. Okay, doesn't usually use that type of data doesn't really help you any, but it is possible. It says choosing the most appropriate measure of central tendency. It says although the mean is the most commonly used average to describe a set, it may not always be the most appropriate. Okay, a lot of times kids, they know average, they want to use the average. Okay, here's an example where it doesn't work very well. It says suppose a company employs 20 people. The president of the company earns $200,000 a year. The vice president earns $75,000 a year. And there's 18 part-timers that earn $10,000 each. We're keeping the numbers easy. Is the mean the best average? Okay, so there's going to be one person making 200,000, one making 75, and 18 making 10,000. So as you do all that math, add them up. That's 200,000 plus 70,000 plus 180,000, because that would be 18 times 10,000. You get a total mean or average salary in that place is $22,750, which, if you think about it, only 2 people make more than that. How is that really? And there's 18 that make less than that. Not a very good way of showing that data. Does either the median or the mode, both of which is 10,000, would better describe the typical salary in that company? Because you have 18 people making 10,000 and 2 people making more. Okay, so the mode is a good one, and even the median would be the same number. Okay, whoops. All right. The mean is affected by the extremes, and that's what we just talked about. Okay, so suppose 9 students make the following scores on the test: 30, 35, 40, 40, 92, 92, 93, and 98, 99. Okay, is the median the best? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. So where's the median? Should be at the 92, right? All right. So if the median is at the 92, does that represent the scores in this? Well, that's an A, right? So half the group made the A, the other half didn't. Okay, real quick story for you. My son was in a class one time, and you can, in certain things in Fort Bend ISD, you can actually see certain statistics for the kids in their program there, what they use as Skyward. And he did something, he couldn't finish it, so he basically got a 0 on the quiz, the temporary 0, until he could fix it. Well, you go on, and it was the median score of the class was a 0, which meant at least half the kids didn't get it done. Okay, and then the mode was obviously going to be a 0, and the average was like a 5. So it was like none of the stats really, where they had to redo whatever they were doing. Okay, so you can see where, if you have a class, your median is 0 on the average, then you got to do something about that. It's your responsibility because something went wrong. Okay, so from that score, one might infer that everybody did well because the middle grade was a 92. But the mean would have said the average was a 69. Okay, which meant it's a failing average. Okay, it says, however, with the spreads of the scores, neither is very appropriate. Okay, so none of those would work very well. Is the mode an appropriate average for the following scores? Okay, so the mode is going to be what? 98. Okay, is that going to really show what all the kids did? Everybody else failed. So obviously that's not appropriate. So the score is 98 is not representative, and because of the large spread of the scores. Okay, 2 really good grades, and then everybody else bombed. All right, it says consider the following data. Okay, so you see these numbers. I got 20, 22, 22, 25, 26, 27, 27, 28, 30, and 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my middle is going to be right in here, 26 and a half. I've got a mode of 27, another mode of 22. Okay, I'm going to have to add them up. Okay, so you have a range. Okay, so now we're going to talk about measures of the spread of that information. So you've known range, take the highest number minus the lowest number. Okay, so 35 minus the 20. So the range between this data is 15. Okay, the median is 26 and a half. Okay, that's what we talked about right here in the middle. Okay, now we're going to get into this different types of measures in which what we call is quartiles. Okay, so if the median between the first quartile, so here's the middle would have been about right here. Okay, let's get some information going here. So the middle is going to be right in here, right? So then you have what's known as the first quartile and the third quartile. Okay, let's clear that out real quick. Oops, gotta clear that out. Didn't clear. There we go. All right, so you have a middle of this half and the middle of this half. The middle of these 5 numbers is 22. The middle of these numbers is 28. So an interquartile range is the middle of the second half minus the middle of the first half. So that is 6. Okay, so when the interquartile range is reported along the median, not only do we know the middle, we know the spread out, how it spreads out from the middle 50% of the data is. Okay, so that interquartile range will tell you basically that 50% of your information is inside that. Okay, so we use that in what's known as a box plot, or some people call a box and whisker plot. It's an older name for it. Okay, so it kind of shows how things are spread out. So it's box plots show only a visual representation of the 5-number summary of the data: the middle, median, the upper and lower quartiles, and the least and the greatest values of the distribution. Okay, the high and the low. Okay, so you get 5 bits of information. Okay, the second quartile is the middle. The first quartile is the middle of the first half. The third quartile is the middle of the second half. You have the highest data point, the lowest data points. Okay, and so you have the first quartile, then the second quartile, then the third quartile, then the fourth quartile, basically. Okay, and so from that information, we can draw what's known as a box plot. Okay, so in this box plot, okay, you'll have a line basically you use. The far right side is the highest number in the data. The lowest number is on the far left side. Okay, but then you mark a dot at where the first quartile is, where the second quartile is, and the third quartile. And then you draw this box that the box goes from here to here to here. Okay, that's a really crappy box, but okay. And then there's a line right here through this one. Okay, that line shows where the median is. All right, so that's how that gets drawn. Okay, so it says where is the minimum and the maximum values? Well, the maximum is going to be out here at 70. The minimum is going to be at 0. The first quartile would be the first dot. The median is the second dot inside the box. And the third dot is where the third quartile is. Okay, so you have a minimum of 0, maximum of 70, median of 20. And the first quartile is at 10. The third quartile is at 35. And that's how you read a box plot or a box and whiskers. Okay, now we talked about in the previous section, we talked about an outlier. Okay, by definition, an outlier is a value that is widely separated from the rest of the group. Okay, but it does have a way of finding if something is an outlier. In the set of scores, 90 through 94, all data is grouped close together and no values are widely spread apart. No outliers. But if I had these scores, I added 21 as a low and 150 as a high, both 21 and 150 are farther than the last of the other informations, which makes them what's known basically as notice it says a potential outlier. Okay, but by definition, an outlier is any value that is more than 1.5 times the interquartile range. Okay, now remember, the interquartile range was Q3 minus Q1, right? So if you find that interquartile range, you've got this number. If you multiply that number by 1.5, either is that number lower than that farthest distance or higher than that farthest distance, then they are considered an outlier. Okay, I'll show you one here in a second. All right, it says outliers are commonly indicated with an asterisk. Okay, but they are not drawn on the lines with what they call the whiskers. All right, so here is a table, bunch of information. Okay, final medal standings in Olympics. Okay, U.S., China with the most, and then you list all of these. Okay, with this, you should be able to find the median of all these scores. Okay, they are in order right now, so you can go and find the middle. 1, 2, 3, 4, 5, 6, 7. So there's 7, that's 14, 15, 16, 17, 18, 19, 20. So we have 20 numbers, so that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 and 11. So my middle is going to be 26. So the Q2 is at 26. Okay. So you go and find those. All right. So then you would find the middle of the other two. Okay. So the median is at 26 and a half. You have these extreme scores. So the high and the low. Okay. We've got the middle of the first half was going to be 17. The middle of the third half is 43 and a half. And you subtract those two, you get your interquartile range. Okay. This should be the box. This is the beginning of the box. That's the end of the box. And this is the line inside the box. Now we need to decide, are these numbers going to be outliers or not? Okay. So it says outliers are scores greater than 43.5 plus 1.5 times 26.5. Okay, notice the numbers we're using. Okay, let's share that real quick so you can see it again. All right, so to find if it's an outlier, you're going to take this number plus 1.5 times the median. Okay, so you're going to take that number, and if it's higher than this number, that's that number, then it's an outlier. If it's less than the first quartile minus 1.5 times the median, which is a negative 22.75, if it's lower than that number, then that's also an outlier. Okay? So, is my 11 and my 110 an outlier? Well, 110 is bigger than 83, so that's going to be an outlier. 11 is not bigger than, or less than negative 22, so it is not an outlier. Okay? So, the 110 and the 100 are both in that list that we had before, both bigger than the 83. So notice it gets an asterisk out here. These are outliers. So here's my next number, because the numbers went from 70 and the next number was 100. So notice there's no numbers in between. So that's now my maximum. And here's my minimum of the 11, excuse me. And then you have your other numbers. Okay. A box plot is used primarily for large sets of data. The stem and leaf plot that we talked about before usually is much clearer display of single distribution. Okay, parallel box plots drawn using the same number line gives us an easiest comparison of medians, extremes, and quartiles. So you can have one box plot on top of another one. Okay, you can use it as comparisons. Says although we cannot spot clusters or gaps in box plots, okay, because you only have those 5 numbers. Okay, if you had more numbers, you could find gaps, but a box plot is not used for finding clusters. Okay, this is with box plots, we do not need to have sets of data, and and are approximately the same size as we did with stem leaf plots. Just to compare data from 2 or more sets using box plots, you have to study the boxes to see if they are located approximately the same places. Otherwise, it's really not going to give you much information. Okay, consider the links of the boxes to see if the variability of the data is about the same. Also check whether the median, the quartiles, and the extremes in one set are greater than those in the other set. So if you have all the numbers are bigger than the other one, you're not going to get much comparisons. Okay. So you have 2 here, earnings by genders and earnings for males and for females. Okay. Notice this box is much bigger than this box. Okay. You also have higher extremes. Okay. This is from the box plot. We can see that the mean salaries for the males have been higher than those of the females. Since the extreme values in median and quartiles for the males are all greater than the females, also more than 50% of the mean salaries for males are greater than those for the mean salaries of the females over the period of time. So you got this median, and all the mean would be in here somewhere, and that's why it's kind of a weird chart. All right, so here is the formula stuff that we got to go through. Okay, variation. Okay, the mean absolute deviation, variance, and standard deviation. Okay, so all of these things you're going to have to come up with, deal with. There are a couple questions on your test with it. I am going to somehow give you a formula, I believe. We'll figure that out. I'm working on the way to get that to you. It says a measure of spread is needed when data are summarized with a single number, such as a mean or a median. The simplest way is to find the range. You can also use the interquartile range, which we've already learned. It says the most sophisticated is a standard deviation, which you've seen like your SAT scores. We'll talk about standard deviation, that kind of thing. All right, so to be able to get to standard deviation, you have to first start with the mean absolute deviation. It makes use of the absolute value from the distance each data plot is away from the mean. Okay, so says then the mean of those distances is found to give an average distance from the mean for each of those points. Okay, here's how you compute it. Okay, it says the measure of the distance from the mean by the you take the measure of the distance from the mean by subtracting the data value minus the mean. I'm going to show you how to do it. It says find the absolute value of each and the difference. The sum of the absolute values is the absolute deviation. Okay, find the mean absolute value deviation by dividing the sum by the number of scores. That's how you find the average of the absolute deviation. So here's what you do. Remember what we talked about before. Okay, so here's how the formula works. You're going to take the first value that you're trying to find, this mean absolute deviation, okay, and you're going to subtract the average. So what you're going to have to first do is you're going to find the average of all the numbers. Okay, so you're going to take the first number minus the average and take the absolute value of it, make it positive. Take the second number minus the average, absolute value, and then you keep doing that until you're done. Okay, so can't move it that way. All right, so it's actually fairly simple. Okay, so here are all my scores. So the first thing you want to do is you want your average because you're going to use it a bunch of times. So you add them up, divide by 5, you get your average. There's your 82.3 or 83.2, excuse me. Now, to find the mean absolute value, you're going to take each individual number, 99, minus the average, okay, which is 15.8. Take the next number, 67, minus 83.2, okay. Take the absolute value of that number, you get a positive 16.2. So when you subtract them, you get negative 16.2. Make it positive. And you keep doing that with the other 3 digits, okay? So now you have these 5 new numbers. You're going to add up these 5 numbers, okay, and divide them by 5, and that is your mean absolute deviation, 12.96. Okay? Pictures of the mean deviation for a given set of test scores. So this is where you see it at. Okay, so here is my mean. Here, this white line, this pink line, I guess it is. Okay, so you have data, and they'll give it to you as your absolute deviation. Statistic people, if you're going to be in statistics, most of you might. You're doing young things. You're not going to do this stuff with your kids. Okay, but I expect you to be able to follow a formula, right? So the variance and the standard deviation of 2 statements of dispersion. All right. So how do I find variance and standard deviation? Okay. So you're going to find the mean of all the numbers, average, subtract the mean from each number, square the difference found in step 2. So you square the numbers, subtract the number, square it, find the sum of all the squares, and divide the sum by n to obtain the variance. Then take the square root of that number to find the standard deviation. All right, so the way it works is this. Again, it's not too difficult. You're going to take a number. Well, first you've got to find this number, right? You got to find this one. Once you know the average of all the numbers you're dealing with, you're going to take the first number minus the average and square it. Now remember, on the MAD, okay, the mean average deviation, okay, you took the absolute value and made it positive. Well, now you're going to subtract the two numbers and square it, which will make it positive. Take the next number minus the average, then square it. Take the next number minus the average, then square it. Okay? Now, keep doing that, and then you're going to divide it by how many numbers you have. Okay? Helpful hint, if this number is an n number of x's, that's going to coincide with that number there. Okay? Now, the other thing I want you to notice is variance. This is the variance right here, the number inside the square root. To find the standard deviation, all you do is take the square root of that final number. Okay? So you have to find the variance first, and then you can find standard deviation. Okay? So here's exam A scores horrible, 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 great, great, great. And then at the exam B, everybody got 50. So showing you how different statistics work. So you can find the mean. The mean would be of exam A is 50. Mean, the average of the exam B was also 50. Same thing. The range, highest to the lowest. For A, it's 100, and for B, it's 0. So it doesn't tell you anything. The mean absolute deviation, however, would be what exam A, the average of it, because when you do the numbers, you get 50 for exam A, you get 0 for B, which still doesn't give you any information because everybody made a 50 on exam B. Okay, so none of those help you. Now the standard deviation, so the average was a 50, so you go 0 minus 50. Okay, and this is of exam A, I know that for that number there. Okay, square it and times 3, because there are 3 zeros and 3 hundreds, right? And then there's 6 scores total, and then take the square root, you get a 50. Okay, exam B, you get a 0. Okay, because there are all 6 50s basically. And 50 minus 50 is a 0, so everything's 0, square root of 0 is 0. The median was a 50 on A and a 50 on B. And the interquartile range, 100 for the first one, and a 0 for the second. Okay, so you can use them, that you get sometimes the same scores. Graphs for normal distributions, or the old bell curve, normal curves. Okay, so it says a normal curve is a smooth bell-shaped curve. Okay, and it's going to have mean, median, mode all have the same value in some of these. All right, the curve extends definitely in both directions, or infinitely in both directions, and gets closer and closer to the x-axis, but will never actually touch it. The curve, it will be symmetrical and has a center point. Okay, that makes it that bell shape. All right, so here's an example of a bell curve. Okay, now the very tip of the bell curve should be your average. Okay, and if you want your scores to be in a bell curve scenario, which they used to use a lot, okay, 68% of all your scores are supposed to be in that first, what's known as first standard deviation. Okay, so half of them will be on above, so 34% above the average and 34% below. That would be 68% of your scores. Okay, then after that first standard deviation, you get your second standard deviation, which is another 13.5% on both sides. So now I should have used up 95% of my score data. Okay, and then you have the last of your data. Okay, it says on a normal curve, about 68% of the values lie within the first standard deviations, which is said in the second one, 95% of all your scores, and then throughout the three standard deviations away should have almost 100%. Says percentages represent approximates of the total percent of the area. All right. When a standardized test was scored, there was a mean of 500 and a standard deviation of 100. Suppose 10,000 students took the test and their scores had a bell-shaped distribution, making it possible to use a normal bell curve. Okay, how many scored between 400 and 600? Okay, it says since one standard deviation on either side of the mean is from 400 to 600, there should be about 68% of the people that scored inside that interval. Okay, so 68% of 10,000 should be 6,800 students should be within that first standard deviation. Okay, how many scored between 300 and 700? That would realm within the 95%. So 95% of 10,000, 9,500 students. How many scored between the rest? Well, that's the last 5%, right? So 98.8 would have scored there. That's why you have 9,980 of the students. So that leaves you with just 20 more students. How many scored above 800? Should be 10 above it and 10 below the bottom. Okay. So suppose that a group of 200 students asked their teacher to grade on a curve. If the mean on the test was a 71, all right, there's 200 students, okay, that would mean, okay, the test with a standard deviation of 7, all right, so the standard deviation would get you out to 78 to 85, and then so your C's would all be in the first round from 64 to 78. Okay, your B's would be the next standard deviation, so there should be 13.5% more. Okay, so you're up to 85. The grade would be an 85, and then the A's would be an 85 or above. Okay, so 85 above is your A. There should be only five A's because there's only 200 students. So that's the top, little bit of the score, right? So on a true bell curve, you need to have 68% of the students make a C. So you would give this many a C. B's would be 27, but then there'd have to be 27 D's and then 5 A's and 5 really lows or bad F's. Okay, so anything below a 57 on your grade scale would be an F. All right, so when students take standardized tests like ACT and SAT, their scores are often done by percentiles. A percentile shows a person's score relative to everybody else's scores. Percentiles divide the set of data into 100 equal parts. Deciles are points that divide the distribution into 10 equal subspace sections. I'd say the nth percentile, but they use R, represented by P to this little r. Okay, so it says a standardized test that was distributed along a normal bell curve had a median of 500. The standard deviation is 100. Okay, so the 16th percentile is 400 because 400 is one standard deviation below the median. Okay, and this I'm not going to test you on. Okay, so you don't have to worry about any of this. I do want to go to this. Okay, this I want you to know how to do because you need to know how to do this. It says Aussie was ranked 25th in the class of 250. What is his percentile rank? So you take the total minus his spot, 25, and you get 225. Okay, take that 225, divide it by the total number in the class, 250, and you get 90%. So 90% of the class had lower scores than him, which gives him a 90th percentile. So that a high number is a good thing, means you're higher on the scale. Okay, in a class of 50, Kathy had a percentile rank of 60. Okay, so she was in the 60th percentile. What is her class standing? Okay, since Kathy's percentile is 60, that's 60% of the total number, or 60% of 50, which is 30. So 30 students ranked below her. Okay, so that meant she was the 20th in the class because you would take 50 minus the 30 to get her position in the class, and you get that 20. All right, so I told you that was long. Okay, you can always go back to it and also kind of look through your e-text also for some other information. All right, but I do hope this helps. All right, good luck.